Solving two-step and multi-step inequalities. We'll start with this example. To solve and graph the solution set, let's first add 12 to both sides. Let's divide both sides by 8. And the solution is m is less than or equal to -3. So in our number line, we'll have a closed circle at -3, and we're shading to the left to represent numbers less than or equal to -3. So that was a two-step inequality. Here's the next one. We want to isolate the variable m, so we could subtract 9 from both sides. But now be careful, when we divide by -3, remember we need to reverse the direction of the inequality sign. So we'll get m is less than -4. And therefore our solution set on the number line will be an open circle at -4 and everything to the left. So just be reminded, whenever you multiply or divide an inequality by a negative, you must reverse the direction of the inequality sign. Okay, here's an inequality involving fractions. 3/4 of some number, y, when I add a half to it, will be less than 7/10. So one thing I can tell just from the way the inequality reads right at the outset is y is going to be a small number. In order to take 3/4 of it and then add a half and still be less than 7/10, I'm expecting some fractional value for y, like y is less than some fractional value. Okay, first thing we want to do is look at the common denominator between 4, 2, and 10. And we're going to use 20. So let's multiply all three terms in the inequality by 20/1. And the purpose of this is to clear the fractions so we no longer have denominators. That first term becomes 60/4 times y, or 15y, plus 20/2, or plus 10, is less than 14. And there's more than one way to multiply a fraction by a whole number. Now we want to subtract 10 from both sides, and then we want to divide by 15. So our solution is y is less than, as I had expected, some fractional value. So y is less than 4/15. Now think on a number line, how would you graph 4/15? Well, it's between 0 and 1, right? But it's a little bit less than a third, because a third would be 5/15. We want y is less than 4/15. Okay, so that was with fractions. Again, our strategy is going to be to clear the fractions so that instead of dealing with the denominators, we end up with integers. Okay, next we have a word problem. John borrows $55 from his parents. They agree to subtract $3 from the loan for each hour he works in the yard. To find the number of hours X John needs to work before he owes less than $30, write and solve an inequality. So remember, he had borrowed the $55, so we're going to start with that. And for each hour he works, $3 per hour is subtracted from the 55, and we want this to be less than $30. So 55 minus 3x is less than 30. We're going to subtract 55 from both sides. We get -3x is less than -25. Now once again, we'll be dividing by a negative, so be careful there. We're going to reverse the direction of the inequality. X is greater than 25/3. Now in algebra, we like to leave improper fractions, but because this is a word problem, it also is helpful to turn that to a mixed number. So X is greater than 8 1/3. John must work more than 8 1/3 hours before he owes less than $30 to his parents. All right, let's move on to something a little bit more complicated. When we have variables on both sides, what do? There's no hard, fast rule for which is the better variable to eliminate, the one on the left or the one on the right. But in this case, if I add 5x to both sides, I'd end up with a positive 7x on the left plus 7 is greater than 21. Now let's subtract 7 and let's divide by 7, and we get x is greater than 2. So we can graph that and open circle at 2 and everything to the right. Okay, this next example, I would like you to put this video on pause, please. And I would like you to try to solve this and graph the solution region. First thing you would have done is distributed, then check that you would have combined like terms. You may have added 6x to both sides at this point and added 16. When we divide by 5, again we get x is greater than 2. So same graph for the solution region in that one. All right, we're going to end by just briefly mentioning some special case inequalities that are likely to come up in your lessons or in some assessments. For the one on the left, when you go to solve this, you're going to probably combine like terms. You're then going to subtract 2x from both sides, and you're going to end up with something that is going to make you look twice. Because there is no variable, you're left with a number 4 is greater than a number 7. Now you know that is not true. Therefore, because it's never true that 4 is greater than 7, there is no solution to this inequality. In other words, no value of x will make that inequality true. Now on the right-hand side, we will distribute the 3 into the parentheses. We will then combine like terms, but when we do all that, we end up with something that will also make you stop and look twice. This one has no variable in the solution. You're ending up with kind of interpreting an inequality between two numbers. Negative 18 is less than or equal to 4. Well, that's true. Always true, in fact. Therefore, there are infinitely many solutions to this inequality. Any value of y will work in this original inequality to make a true statement. So those are your two special cases.